Hello, everybody. I would like to go through one multiple regression problem and show it how to use Excel for it using the data analysis. Uh, First thing, let's read the problem carefully. When you're looking at the typical problem, like what we have in our PowerPoint slideshow, it says you work in advertising for the New York Times and you wanted to find out the effect of ad size in square inch and newspaper circulation in thousands of copy on the number of ad response which have been expressed in hundreds of response. So the typical problem is like this. The response variable, which in this case y, it's given, and the size of ad is given as well, and the circulation is given. And so we take these to Excel, and I try to use it the same order. And now when I'm using Excel, the only thing I have to be careful is my x's must be adjacent to each other. And so in this case, that's true. And the y response is in a first column, column A, and size of ad in the second column, column B, and number of circulation in the third column, column C. Now, usually I start this problem by running correlation analysis first. What the correlation analysis does, it gives you a feeling about how strong the correlation between your y and x1 and your y and x2 would be. So let me go to correlation, and here I'm going to go to the correlation using the data analysis. I'm going to put all the variable here. So I'm going to put from A1 up to C7. And so all the input would be, all the variable actually, input range would be A1 to C7 in this case. I want to have a label in the first row, and I want to have the output on my screen. So I've asked for to put it in E1 right here. Now, if I ask for the correlation, Excel is going to provide that, and it's very useful to start this way. And now, when I'm looking at the correlation, it's given is the matrix, but since it's a symmetric matrix, only the lower diagonal is given. So here I'm looking at the correlation between response and size. Obviously, it's here. So let me color that. And the correlation between number of response and size of ad, it is 0.9093. Now the correlation between response and circulation, let me do that, that's 0.9311, and that one actually tells me that maybe circulation is related higher than size in this particular problem. But anyway, the next thing I'll do usually go through the correlation, go through the regression itself. The typical problem might need you to go through plotting as well, plot y versus x1, plot y versus x2, which we have done that for just simple regression, y versus x. Now let me go through regression analysis for this problem. Remember, this is the one I want to predict, response variable, and I am using x1 and x2 to do that. So let me go to regression analysis and ask for running this regression multiple regression model. And so I'm going there. Let me start from scratch more or less. I am gonna put input y range. It is from A1 to A7. Input x range is I have to put both of them, and that's why I said you need to have all your x variables adjacent to each other. Here I have it in B column and C column. Even if I have more x variable, I have to put them adjacent to each other. Now label is in the first row. I want to have the output somewhere on a new sheet, I usually ask for standardized residual and normal probability plot. So let me run the regression. And it provides me with a lot of information initially, so I got to be a little careful. It's a little confusing, and I may not need all of this information. But let me enlarge it first. Uh, I start with R squared. It is fairly high. It's actually high, 0.973. So let me highlight that. And let me put a color on that one. Basically, it says that 97.36% of variation in response variable could be explained by x1, which is in this case size, and x2, which is circulation, which is very high percentage. In multiple regression, we use adjusted R squared. And adjusted R square, what it does, it takes into consideration how many independent variables you have. The more independent variable you have, theoretically, it should increase your precision. And adjusted R square try to take that into account and say if you have one multiple regression with two variables and you have another one with 20 variables, obviously the 20 variables has to be penalized because it's using more. So adjusted R squared takes into account the number of independent variables. In this case, adjusted R squared I have is 0.956. Again, it's very high. So let me color that one too. Now, when it comes to multiple regression, we use what is known as overall testing. Overall testing is done based on what is known as ANOVA table. And ANOVA table, look at the variation, and this is basically sum of square of regression, and this is sum of square of residual, and then eventually come up with f value and significant of f, which is the same as the p-value we have used previously. So let me mark that as a p-value. Now, if I have to test for overall model and the ratio, I say all slopes are zero. It means basically if I end up with this, it means all the slopes are zero, statistically speaking. It means that there no relationship between my x values and my y's. So it means basically I wasted my time. There wasn't any relationship between my x1 and y, my x2 and y. And the alternative, we say at least one slope is not equal to zero. And that means that at least one of the variable contributing. So by looking at the, and let's say alpha is 0.05. So here, when I'm looking at the p-value, obviously my p-value is here. And I'm comparing that with alpha right here. My p-value is bigger. I'm sorry, my alpha is bigger than my p-value, so it means I'm going to reject HO. I'm going to reject this one. So when I'm rejecting this one, I'm saying this is true. At least one of the slope is not equal to zero. Now, it doesn't tell me which one, but it tells me at least one of them. And now the typical problem is like this, so it means I have to go and continue. Um, and now I'm looking at this table. I guess up to here, I think that's what I really need. Whatever I have after may not be that useful in this case yet. So let me make sure I see everything clearly, what I have. giving hard time. Now, looking at the information here we have, let's look at this one first. Um, Now, looking at this information we have, obviously my slope is 0.0249. That's the slope for size. And then when I'm looking at further, I see the standard error for slopes. That's the slope standard deviation for x1. And then I have a t-statistic, and I have a p-value. So if I am running a test, I could run a test for size, slope of size. Let's say under HO, slope for size is equal to 0. Uh, Under alternative, I say slope for size is not equal to 0. And all I need to do, as long as I have these, I can look at the alpha. Let's say alpha is 0.05 still. And now my p-value is here. Obviously, my alpha is more than p-value. I'm going to end up rejecting this one. I'm going to reject this one. Therefore, I'm saying slope for size is not equal to 0. It means size is actually contributing. It means there is a linear relationship between size of ad and number of response. I can do the same thing for circulation. So I can all just say slope for circulation equal to 0. Slope for circulation is not equal to 0. And therefore, now I'm going to look here. Uh, this is slope for circulation. Let me call it that. And then the t-value is here. And more important, the p-value is here. Let me do the p-value here. So as long as my alpha is 0.05, alpha is more than this. So again, I'm going to reject HO. I am going to say that based on this information, circulation is contributing and slope for that is not equal to 0. It means there is a linear relationship between circulation, number of circulation, and number of response. And lastly, in a typical problem for multiple regression, we have to perform residual analysis. It's very, very similar to simple regression. And I'm already asked for this one, predicted response value predicted Y. Let me copy that and put it somewhere here. And I'm going to also look and find the standardized, look at the standardized residual. It's right here. Let me put them adjacent to each other. And usually all I need to do here, I have to come up with a plot of my standardized residual. So let me do that. I'm going to highlight this and go as for scatter uh, diagram. The plot is given. Let me move it somewhere so I can see it better. Now I'm looking at this plot, And basically, the plot, I have a zero line here. Um, Everything must be randomly and independently distributed. And then we say the standardized residual should be distributed with mean 0 and standard deviation of 1. That implies between -3 and +3, that should be all the between -3 and +3. And all the residuals should be there. So in this case, that's the case, all of them between -3 and +3. Then I go to -2 and +2. Again, I should, based on normal distribution, 95% should be between -2 and +2. In this case, all of them they are. And then I go to -1 and +1, and I count again. Uh, Here I look, everything is between -1 and +1 except one of them, which is not that bad. If I go through, it's 5/6 of them they are within, which is like 83% within -1 and +1, and just one of them outside. Lastly, it's always good to look at the normal probability plot. And normal probability plot, if I go there, it should be on a straight line. And in this case, it's almost on a straight line. So I can conclude overall that the residual analysis indicate there is no issue with this model. Um, I think this is very consistent with what I did in my PowerPoint presentation. Please go through this with care. And if you have any question or any concern, I would be glad to answer. Thank you for watching.